Okay, so, when you're looking at like acceleration, it's positive, how, because he said it's just after the fall, that's not the hand moving. Oh, I thought he was on, I mean, in line, it's accelerating positive, velocity is positive, so it's accelerating positive. And then it's not including B, because when we were arguing about when we were moving, it's negative, because it's starting to go down. I personally think it's zero, it's technically negative. And then it's including B because, like we said, they're going down. And obviously it's including C and D because it's still accelerating down. Does anything cause it to
All right, shall we look at this as a group?
Can I ask you a question?
Yes, Stephanie.
So after the ball leaves the hand,
Right.
would it immediately start decelerating, or would it
It immediately starts slowing down.
okay, so at A, would it be slowing down?
Yes.
And he said the velocity is
From A to B is negative, and then from Z to C to D.
It looks like we're not quite ready to look at this as a group. Do YouTube videos get any more exciting than this? I don't think so. There's the anticipation of how many students will fall for the same old traps.
All right, go on. Let's come on back. I always hate to cut off the conversations. It's that, to me, a delicate balance of at what point is it too much. So, are you gonna do it all from there? Okay. All right, so personally, I recommend starting with the easy stuff first. So, position. When is it plus, minus, or zero?
It's always positive. Always positive.
Always positive. Okay. Because it never touches the ground, and the ground is the origin, and it's on the positive side the entire time. So I would write that over here as A, comma, D. They indicate from time A to time D, including them. And the next of those, it's never zero, never negative. All right, displacement. All right, if you have one that's always something or the other, it's simple enough to hit that. But when you start getting into displacement, velocity, acceleration, sometimes it's helpful to go, when is it zero? So let's just start out with, when is the displacement zero?
A and C.
And nothing in between. So A, C. Now these charts over here are just different ways of presenting the exact same information. On the test, I gave 4 different ways of presenting it. Pick one. I have had students pick more than one or do all 4. If you're gonna do all 4, please make sure that your answers actually match each other. I have not asked a student about what was going through his or her head when they decided to answer in 4 different ways differently. But so here I would just write plus, 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 plus. Here I would just shade in the positive. All right. A and C. So over here, A and C are 0, or in this chart right here, A and C. All right. What about between A and C?
Nothing.
Not including A, but including B, it's positive. And including B, but not including C, it's positive.
Okay, so So we can write that as A comma C. Now, if you want to break it up into parts and do if you wanted to write this as A, B, bracket, and then B, C, parenthesis, bracket B, this and this mean the exact same thing. So it's positive in between. And what about after C?
Not including negative.
C, comma, D, both in parentheses.
Not including C. Assume we are including D. Now, these other two charts have the benefit of you cannot go for an individual quantity, you can't go from positive to negative without going through zero. So there's got to be, there was one test I messed up. There was one place where I didn't label the part correctly. In that one example, you could go from positive to negative just because zero I didn't put on there. However, if I've done it right, that should not be the case. So we're going to go through zero, so it's sort of showing, in essence, is a crude drawing of the displacement. It's going to look something like that. Velocity. Where's velocity zero? Actually, before we continue, displacement, questions? Or position, any questions up to here? All right, when is the velocity, so it's zero at V. Zero at V. Okay. When is it positive? A to B? Am I including?
Not including B.
Okay. A to B, not including B. So, bless you. A, B. Now, just because you hit zero doesn't mean it's automatically going to flip signs. It is possible to go from plus zero to plus. But if I am going to go from positive to negative, I've got to go through zero. So what is a negative?
B to D, not including B.
And if you're doing the first notation with brackets and parentheses, please make sure I can tell the difference between your bracket and parentheses. It's especially, usually it's not a problem, but occasionally you get someone who do this and they go, oh wait, that should be a bracket. And now I have to sort of guess what came first. Or they do that and then they sort of amend it. I'm still supposed to guess. All right. Questions up to here?
Okay, I just have a really small question. So earlier when we were having that argument, was acceleration negative in that situation because, wait, no, I'm sorry. Was the answer when we were like arguing stuff between it being zero and negative, it was negative because we were talking about acceleration, not velocity, right?
Correct.
Okay, that's why I was confused. Thank you.
All right, so what can you tell me about acceleration? When is it positive, negative, or zero?
It's all negative.
Pardon?
All negative.
Yes. As it's going up, it's slowing down. Velocity is positive, acceleration's got to be negative. On the way down, it's speeding up. The acceleration and velocity have to be the same sign, they're both negative. at the turnaround point. The only reason it can't be 0, because if it were 0, the ball would be thrown up, it hit that spot and stay. So there's got to be something pulling it back down, because it does come down. So the force of gravity is, or its weight, is acting on it the entire time, pointing downwards. Acceleration is negative. That is a gateway problem. You ready for a test level problem?
Sure.
All right, there's the enthusiasm I want to hear.
Yeah.
In terms of presenting, another advantage of these, this has sort of a sense of the graphs. Oh, actually, we probably should do graphs next. One of the issues that some students have this method here, when they don't really understand, is they view A, B, and C, and D as points in space and not moments in time. And they only do, A and C are the same to them. And A and C are not the same. They're different times, moments in time. Also, there's overlap. If you put a bracket here, then that means C is included in positive and C is included in 0, because C is written here. And it can't be two categories at once. And so an advantage of these is that it's harder to duplicate. Easier in that one, but on this one, as long as you've got just one symbol in each box, you haven't left anything blank or duplicated. All right, in terms of the test level problem, any of these presentations seem better to you at the moment?
I like that bottom
Bottom right? Okay, do that one then. The other group, a majority of the people, not just the person who spoke, but the majority of the people like this method,
Yeah.
which surprised me. But
I just have a question. So earlier, didn't you say that if velocity equals 0 or acceleration and force equals 0, then that meant the other ones had to equal 0?
no, if the change in velocity is 0, acceleration is 0,
Okay.
and the total force is 0. It's the change in velocity.
Okay.
All right, test level problem. There it is. All right, so it goes from A through J. These are all times. A is the starting point. Now, on a test, and on the master set, I would have this listed out more formally. I'm gonna, for the sake of time, I'm not gonna write it all out. C and I, these are the same, the object's in the same position at those two moments in time. B and J, same position at that moment in time. D, H, E, G. It is not returning below the line. It's on top of the line, but I need to somehow differentiate motion to the right, motion to the left. This is a two-dimensional problem. I only care about left and right for this one. So I'm just gonna make to the right positive, because why not? There is friction on this sloped part. The shorthand for friction that's just shorthand for there is friction. That stands for the coefficient of friction is not 0. It is frictionless everywhere else. D, E, G, and H are all on the flat part. So I try to draw them oriented on the flat part. C and I are on this slope right here. F is on that slope right there.
So D through H is flat.
Not F, but D to E and then G to H is on this flat part.
Okay.
So D is when the box is completely on the flat part. E is when the box is D is the first moment that is completely on the flat part. E is the last moment that the box is completely on the flat part. G is the first moment coming back that is completely on the flat part. H is the last moment it's on the flat part before starting to move up.
And is F level with A?
No, F is slightly below it. I need to establish an origin, so we'll make this the origin. And I think that's it. Let's see. One person to express an opinion, like that display. So I've got position, displacement, velocity, acceleration. I have A, B to B, B, D to C, C, C to B. Oh, that's it. Lost, that should be on there. H. Oh, no, that's right. H. H to I. There we go. Okay. Where is the position equal to 0? Oh, sorry,
Is that a vertical origin?
pardon?
What the origin on that?
The object is at the origin at times D and H. So this is, so where is the position equal to 0? So it's 0 D and 0 at H. All right? When is it positive?
So origin is D through H. What's the starting point? A again?
Yes.
It's E, G, F is part, is it?
B, G, and F is positive? Is that what you said?
Yes.
So E, G, F. What about in between those times? Even you're nodding your head.
Yeah, it's positive between all of those points.
And it will have some people take that first way we displayed it and just write in those moments of time and nothing in between. Let's not forget there are times in between. All right, so positive because it is on the positive side of the origin after D, time D, and up until H. And negative?
A, B, C, J, I. Just like, yeah. Okay, and then C through D. And then B, I like everything.
If we did the first part correctly and we know that there is negative, then everything else should be negative. All right. Displace, questions? All right, displacement. A is,
Oh, you're.
A is 0, and the rest are positive. Just to, a test taking tip. Some students will look at position and displacement and blank on a test, and they'll go, I'm not sure which one's which. Why don't I just put the same answer down for both and see what I can get? If you put the exact same answer, I will tell you right now that neither row, or none of the 4 rows will be identical. If you put identical answers down for 2 of the rows, I will give you credit for one of them and no credit at all, not even partial credit for the other one. All right, velocity. Where is the velocity equal to 0? Oh, I didn't state this, it starts at rest.
It starts at rest.
It starts at rest, it ends at rest also.
A 0.
All right, A is 0.
I think F would also be a 0.
Yep, because it has to stop, it turns around at F, so it has to stop at F. And it's 0 one more place. Somebody just said it?
J.
Yep, Jake. All right, so now we have our zeros, assuming that that is done correctly. I got 2 segments I need to fill in. I got between the first 2 zeros and then the last 2 zeros.
The first 2 are not between the first 2 zeros and positive.
Yep, because it's moving to the right in the positive direction. Plus, 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 plus. All right, and
The rest are negative.
now the tricky one. Questions up to here?